Okay, I'm going to start by just going through this with graph paper. I printed this off, labeled the axes. It's nice and spread out. Okay, you want your graph to be as big as possible. I labeled my axes as well, forces in newtons. I'm leaving the displacement in centimeters. You might want to do meters. I got this from pagingsupermom.com. It ended up being 1/4 of an inch blocks. I think it's better if you use metric, but I'm going to be able to work with this. It'll be fine. Okay, so here we go. We got to place our data. So when the force was 0.2 newtons, the displacement was 1.1 centimeters. Okay, I actually made my scale go up by 0.2 each time and then 1 centimeter each time. So this dot is going to be very, very close to this first grid line here. Okay. Put it right there. All right, next, 0.392. That's just under 0.4. This guy's just over 2. So what's that going to look like? Just about right there. Okay, 0.981 will be really, really close to 1. And then we have 2.3. Sorry, 4.9. This guy's going to be, I just want to do a good job here. Really close like that. All right, moving on. 2.45. It's going to be halfway between 2.4 and 2.5. There's somewhere right there. And then 12.8. Okay. The last point. Right on this grid line, which is nice. Note 4.9, that's going to be easy. Okay, there's my data. It's hard to get it all in the frame. Let me pull you up a bit. Okay, here we go. There's my data. It should be really, really close to linear. I didn't give you too confusing of data. But to do a line of best fit, you want to get your ruler down, okay, and you want kind of the same number of dots below the line as above the line. However, this one is so close to straight, I think I can pretty much hit all of these dots. Okay. So I'm not saying the assignment question will be this nice where all the dots will hit the line. I didn't do a great job because actually you can see my dots below the line, but it's definitely acceptable. All right. The last thing we're going to have to do is get the slope of this line. Now that's also not going to be too much of a challenge. You just pick any 2 points that the line goes through. Try to pick your best ones. Like this point looks like the line goes right through the middle. I might choose that one. But another really good tip and strategy is to pick points on the line that weren't necessarily in your data table, but that go right through grid lines on your graph paper. I'll show you what I mean. This one's going to have a, like, this one looks really, really close to exactly here. I realize that's close to my black dot, but it's like 0.2 and 1. And then I might just choose this guy, actually, the one from your data table. So I'm going to use 0.2 and 1, and then this data point, which is really, really close to 5 centimeters. Oops, right here. Okay, so let's get our slope. Notice my line doesn't go through the origin. It doesn't quite hit 0, 0, which is totally fine. But most people want to use that point as one of their points in their slope calculation. In this example, I don't think you can because it doesn't go, the line isn't touching it. So I just want to remind you, I'm using the point on the grid line here which is 1, 0.2. So I'm not necessarily using this data point. What I'm saying is that this line goes through the grid line more closely than the dot I made. This was a challenging graph to communicate that with because it pretty much follows the grid lines anyway, but I'm using the point on the grid line and then this actual data point, which again was 4.9 and 0.981. Okay, so let's do our slope, rise over run. It's going to be 0.981 minus 0.2 over 4.9 minus 1. Let's see what we get. Okay, so I get 0.20. These were newtons and these were actually centimeters. I'm going to do this example another way using my calculator. We'll see what we get in the next video.